covered our voice code normal form. Let's start with the fourth normal form now. Let's explore the rules, regulations for this normal form, which says it should be in the voice code normal form and there should not have any multi-value dependency. Now there is another type of dependency. You learned about partial, full functional dependency and transitive dependency. Let's learn about multi-value dependency, which is essential for our fourth normal form. Okay, so multi-value dependency, what it says, yeah, I have also included one example here. So a table is said to have a multi-value dependency if for any functional dependency it tends to be for a single value of A, multiple value of B exists. A should be unique, but we can have multiple values. Then in that case, we will say there is an existence of multi-value dependency. And to ensure that the table have multi-value dependency, you should make sure that there are three columns at least. And for a relation R, which is having three attributes A, B, C, if there is a multi-value dependency between A, B, C, then they should be all independent of each other. There should be no dependency. Okay. So let's start with one example. So this is a college enrollment table with the columns SID, course and hobby. So if you see, okay, if you see here in the table, the student ID SID 1 has opted for two courses, science and maths, and two hobbies, cricket and hockey. So, well, these two records of student ID SID1 will give rise to two more records as shown below because one student, two hobbies exists. Hence, along with both the courses, these hobbies should also be specified. So, can I say there are some existences of multi-value dependency? Yes. Okay. And what are those? That is our SID, multi-value dependency exists. So, for that, this is the sign and course. So, SID can determine the multiple values of courses and multiple values of hobbies too. Understand? And in the table here, as there is no relationship in between the course and hobby, so they are independent of each other. Okay, now understood the concept of multi-value dependency. So to make the relation satisfy the fourth normal form, we need to decompose the two tables. So how to decompose it? See, where there are not any dependencies, multi-value dependencies mostly, based on that we can divide our table. So can I divide like this? SID course and SID hobby, because SID is determining course and SID is determining hobby based on the functional dependencies. Correct? So see, this is how both of them are divided now. Now if you see, one single value of SID is determining multiple values of courses and multiple values of hobbies. So now our table is in the fourth normal form. Okay. So hopefully you got a clear picture or clear idea about all the normal forms. Okay, well, so what's next? Next is we need to see some practical database design using the normalization. Let's start with an initial contracting company ERD. So this is a picture of two entities, employee and project, and here the primary keys are also defined. And let's see here. Another one entity comes to picture, that is job. Okay. Uh, so here, the already it has seen that the employee, each employee has main job classification, and any job classification may be held by many employees. Some job classification have not yet been staffed, therefore the employee is optional to job. So because of there is a transitivity dependency somewhere in the figure 6.13 in between these two. Okay. um, so it is modified by in adding a new entity job here. Next, another part of database design using normalization. So there is a many to many relationship between employee and the project. Okay, so if you have many attributes of employees which are combinedly or uniquely identifying the many attributes of project, so there is a many to many relationship, and it gets sometimes it gets complex to define the relationship in a proper way, and it's not ideal. Okay, so what to do with this? Here, what you can do, you can incorporate a new entity which is called your addition of a third next new entity called assignment, and assignment has a primary key assignment num. So now one employee has a many relationship with assignment. One employee can have many assignments, and one project can have many assignments, requires many assignments as well. Okay, these are some of the design strategies. Then next comes our denormalization. So denormalization is a strategy which is used on previously normalized database. Okay, so you have already divided relations, you have already normalized it. Now you want to again increase the performance, you want to make it more faster and resourceful. So that now you can move on to denormalization. So denormalization is a process of trying to improve the read performance of a database at the expense of losing some write performance by adding redundant copies of data or by grouping of data. So this is the denormalization examples using redundant data, derived data, pre-aggregated data. This is also one type of derived data, and some information necessities. So using all this, just read through all the um, examples and see how they are related and enhancing the performance of denormalization. Okay, so that's all in this chapter, that is our normalization, and hope you had a clear idea about the normalization.